Welcome to Brain Vision.
Our question says that the magnetic field of the Earth at the Earth's surface, which I call B sub E, is 1.0 times 10 to the minus 4 Tesla. And it wants us to figure out what the magnetic field strength will be at a distance r of 13,000 kilometers, or 1.3 times 10 to the fourth kilometers. Well, another value that I'm going to use is the radius of the Earth, r sub E, which is 6.38 times 10 to the third kilometers. So if I write out the expression for the magnetic field of Earth, B sub E, it looks something like this. It's mu naught, magnetic permeability of free space, times mu, where mu here is what I'm going to define as the magnetic dipole moment of Earth's magnetic field. So mu naught times the magnetic dipole moment, mu, divided by 2 times pi times the radius of the Earth, r sub E, cubed. Okay? And then the magnetic field at a distance r away, we'll call this B prime, is going to be equal to mu naught times mu, where since mu naught is just a constant, it's the same for both. And mu is the magnetic dipole moment of Earth, so that's the same for both. And then this is also divided by 2 pi times, this time, times r, the distance we are above the Earth's surface, cubed. So everything in these expressions except for the radiuses are the exact same. So if we take the ratio of these two, everything that's the same is going to cancel except for the radiuses, which we know, and we can go ahead and solve for B prime then. So let's get a new page going and I'll show you what I mean. So if I take B prime and I divide it by B sub E, what do I have? Well, if we look at the expressions for B prime and B sub E, everything in the expression is the exact same. So dividing one by the other is going to cancel all the like terms. And the only thing that's going to be left are the terms that aren't the same. Or in other words, B prime divided by BE is going to be equal to R sub E cubed divided by R cubed. So since the R's were in the denominator of those, they ended up flipping, right? So the RE is on top and the R is on bottom. So we can solve for B prime then, and we have B prime is equal to R sub E cubed divided by R cubed multiplied by B sub E. We know all the values in this expression, so we plug them in and we find a magnetic field magnitude of 3.6 times 10 to the minus 6 Tesla. So it is smaller, and that makes sense because we are now farther away from the center of Earth where the magnetic field is being generated. We can box that in as our